I am Dr. N. Satyeshila, Assistant Professor, Department of ECE, Rohini College of Engineering and Technology. The course code is 24EC304. Course name is Electronic Devices for Industrial Applications, Unit 1, Fundamentals of Semiconductors and Diodes. The lecture topic we are going to discuss today is Schottky diode. On completion, the students will able to know how the biasing is done for Schottky diode, applications of Schottky diode. Schottky diode can switch on and off much faster than the PN junction diode. Schottky diode produces less unwanted noise than the PN junction diode. These two characteristics of the Schottky diode make it very useful in high-speed switching power circuits. When sufficient voltage is applied to the Schottky diode, current starts flowing in the forward direction. Because of this current flow, a small voltage loss occurs across the terminals of the Schottky diode. This voltage loss is known as voltage drop. A silicon diode has a voltage drop of 0.6 to 0.7 volt, while a Schottky diode has a voltage drop of 0.2 to 0.3 volt. Voltage loss or voltage drop is the amount of voltage wasted to turn on the diode. Symbol of Schottky diode. The symbol of Schottky diode is shown in the figure below. In Schottky diode, the metal acts as the anode and N-type semiconductor acts as the cathode. Metal semiconductor junction. Metal semiconductor junction is a type of junction formed between a metal and a N-type semiconductor. When the metal is joined with the N-type semiconductor, metal semiconductor junction is also sometimes referred to as MS junction. The metal semiconductor junction can be either non-rectifying or rectifying. The non-rectifying metal semiconductor junction is called ohmic contact. The rectifying metal semiconductor junction is called non-ohmic contact. Schottky barrier. Schottky barrier is a depletion layer formed at the junction of a metal and N-type semiconductor. In simple words, Schottky barrier is the potential energy barrier formed at the metal semiconductor junction. The electrons have to overcome this energy potential barrier for its flow across the diode. The rectifying metal semiconductor junctions forms the rectifying Schottky barrier. This rectifying Schottky barrier is used for making a device known as Schottky diode. The non-rectifying metal semiconductor junction forms the non-rectifying Schottky barrier. Forward biased Schottky diode. If the positive terminal of the battery is connected to the metal and the negative terminal of the battery is connected to the N-type semiconductor, the Schottky diode is said to be forward biased. When a forward bias voltage is applied to the Schottky diode, a large number of free electrons are generated in the N-type semiconductor and metal. However, the free electrons in N-type semiconductor and metal cannot cross the junction unless the applied voltage is greater than 0.2 volts. If the applied voltage is greater than 0.2 volts, the free electrons gain enough energy and overcome the built-in voltage of the depletion region. As a result, electric current starts flowing through the Schottky diode. If the applied voltage is continuously increasing, the depletion layer becomes very thin and finally disappears. This is a diagram of forward biased Schottky diode. Reverse biased Schottky diode. If the negative terminal of the battery is connected to the metal and the positive terminal of the battery is connected to the N-type semiconductor, the Schottky diode is said to be reverse biased. When a reverse bias voltage is applied to the Schottky diode, The depletion width increases. As a result, the electric current stops flowing. However, a small leakage current flows due to the thermally excited electrons in the metal. Reverse biasing is shown here. If the reverse bias voltage is continuously increasing, the electric current gradually increases due to the weak barrier. If the reverse bias voltage is largely increasing, a sudden rise in electric current takes place. This sudden rise in electric current causes depletion region to break down, which may permanently damage the device. Application of Schottky diode, rectifier, voltage clamping, TTL in digital devices, fast switching, digital computers. The frequently asked questions are: what is the difference between Schottky diode and PN junction diode? Explain the working of Schottky diode. Thank you.